Hello everyone, my name is Romulo and today I will present the work entitled Towards an Internet of Multisensory, Multimedia and Musical Things environment. This is the agenda of my presentation, and I will begin with a brief introduction to the motivations for developing this new area of research. But first, it's worth giving a brief introduction to the Internet of Things as a whole. This field was created by Kevin Ashton in 1999 to refer to the use of RFID tags in controlling a supply chain. With developments in this field, several definitions have appeared for this area. But in general, they all agree that IoT is a set of various objects through exclusive addresses, are capable of interacting with each other and cooperating with the neighbors to achieve common goals. It can be used in various applications such as transport and logistics, utilities such as controlling energy grids, smart cities, and the like. Due to the development of devices in terms of processing and memory, they also began to allow the exchange of multimedia content such as text, audio, video, and etc. This gives rise to a new area called the Internet of Media Things. Io3MT applications that deal specifically with audio can be understood in a new area, the Internet of Sounds. This new field of research aims to establish an interconnected ecosystem of devices that facilitated the exchange of sound-related content. This will facilitate the creation of various activities such as interaction in artistic environments, real-time audio retrieval, soundscape composition, and the like. It can be divided into two other new areas, the Internet of Audio Things, which is a specialization of IoT for dealing with audio, and the Internet of Musical Things, which is a collection of ecosystems, networks, musical things, protocols, and services related to music over the network. Despite the numerous similarities, these fields are traditionally treated as disparate areas, where one field does not take advantage of the other. Furthermore, Internet of Musical Things predicts the use of multisensory and multimedia information, but they have not actually been implemented in all environments. In this sense, we saw the need to define a new area called the Internet of Multisensory, Multimedia and Musical Things, which will basically place these three types of interaction at the same time and in the same place, where one will be able to exercise control over the others. So in this paper, we will propose a reference environment based on several areas of computer science and humanities to then carry out a proof of concepts for this environment. To validate it, we run 10 tests and measure in quality of services. Before getting to architecture, it is important to look at some related work. Citing then the Io3MT environments, we have the first model of Turquet, Viola, Fazekas, and Barté, which is a differentiator focuses on a semantic architecture and use of the SparkL language. The second example is the Turquet and Barté model, which seeks better interaction between participants in the environment, and as a difference, it features the use of a smart modeling. The third model is a proof of concept for the Sunflower Protocol, which provides a series of predefined messages for communication between those involved. And the fourth and final model was created by Centenaro, Cesari, and Turquet, and seeks to make Internet of Musical Things concepts to mobile networks. Despite the differences, some points are repeated in most of them, such as the use of UDP protocol in network communication, OSCC as a multimedia protocol, Pure Data as an audio engine, and Python as a procedural language. Having overcome this discussion, we move on to the multimedia models. They will have some general features too, such as immersive content, which is the user's ability to engage with the created application, avoid content delay in media presentation, synchronization between sensory effects and media objects, description of the devices, which will indicate the functionalities, the protocols, accepted file formats, and the like, and finally, they should have interactivity. Coming now to the environment design, I start by highlighting its division into layers. So we will have a things layer responsible for visualizing the data captured in the physical environment. Next, there is the link layer, which connects these objects to the network. Then, the network layer itself, which will route packets between participant elements. The middleware layer, responsible for data management, such as service discovery, connecting or disconnecting users, and the like. And application layer, which will provide the services requested by users. About the features of the devices, they must produce or react to at least one of the three types of information that will be present in this environment. They should have wireless communication, they must be controllable remotely, customizable and upgradable. They must uniquely identifiable, scalable, and show persistence, which is the ability to remain functional even in the face of possible failures. For protocols, we have IP for addressing packets. Transport protocols, TCP, can be used for sending video and control data over the network, while UDP is used for audio data. And to control multimedia information, MIDI or OSC can be used, or even both together. Regarding the technologies used, we suggest the Nested Context Language, also known as MCL, which is an authoring language for multimedia content, known for functioning as a glue, that is, establish relationships between multimedia content without specifying how they are implemented. This makes it very easy to program. However, some problems arise, especially in mathematical processing and dealing with tasks that are outside of the scope of the language. An alternative to this is to use a procedural language like Lua, very famous in game development, but which was created precisely to allow communication between different languages and applications. For this language to be independently of the platform, a middleware is needed for this, so we use Jinga, and as an audio engine, we use Pure Data. After these clarifications, we created an application to validate these concepts. Basically, it works as shown in the figure, so the sound of a microphone and guitar were captured by a computer A and sent over the network to a computer B, which will organize all the sound content with other media and sensory effects using the languages I mentioned in the previous slides. Basically, it works as shown in the figure. The sound of a microphone and guitar were captured by a computer A and sent over the network to a computer B, which will organize all the sound content with other media and sensory effects using the language that I mentioned before. After the tests, we are able to access some results. As I say, we did 10 tests lasting 5 minutes each. And due to the expressiveness factors, the number of packets captured in each of them was different, and with these values illustrated in the table alongside. We measure latency, which is the time it takes for the packet to travel between the sender and the receiver, jitter, which is the standard deviation of the latency, and the throughput, which is the number of packets sent in a time interval. The latency for the audio data vary between 1.59 milliseconds and 1.62 milliseconds, while the control data lengths had values close to. Jitter followed these low limits, while the packet throughput varied between 0.5 and 1.2 packets per second. These low values and within the limits for this type of presentation are due to the dedicated network for the system, which was precisely designed to support this application. Finally, we make a comparison between our model and those proposed for Internet of Musical Things. For the differences, I highlight the different types of media used, in addition to this focus on multisensory effects. The protocols used are very similar. And the same goes for programming language, although our model also uses MCL, which does not appear in the other environments. Well, to conclude, our paper presents an environment that serves as a proof of concept for the Io3MT area. We had promising results in terms of quality of service and the approach for artistic performances involving the three contexts that give this area its name. And furthermore, we propose the use of NCL and Jinga in artistic presentations. Despite this, some limitations can be observed, such as testing only on a local network, which means that it needs to be improved to cover more devices and more users. And the system still requires a lot of cognitive load and a certain configuration time, which are aspects that we have to simplify. For future work, we intend to evaluate the user experience, create new modules and tags for NCL to support interactions in this way, create new use cases for this area. So that's it, guys. Thank you for your attention. I invite you to read our article in full, and if you have any questions or suggestions, I am at your disposal. Thank you very much.